So that was quite interesting. So as you saw, we were able to answer a lot of complex queries on the application. And because of this great technology that we have built and are now exposing it to our enterprise partners, we have been able to acquire 60,000 developers on the Roundify platform that have released over 1,200 products. In addition to that, we have also partnered up with 11 automotive companies like Honda, Hyundai, TSA, and yes, the number keeps on growing and future really looks bright. So how are we able to build sophisticated speech engines that can recognize answers to these complex queries? Well, the general approach has been to take two different steps. The first one is to use an ASR engine to take in your audio query and then convert that into text. And then there's an NLU engine that processes the text string and gets the context, does some post-processing and gives you an answer. So for example, when I ask a question like, what's the weather in Toronto? It will first convert that into a string, then the NLU engine will parse the string, get the weather intent for the city Toronto, make a API call to weather.com, and process an output for the user. This is generally slow and of course can be inaccurate because there are multiple steps. So one thing that we have been able to do uniquely at SoundHound is merge these two engines, the ASR and the NLU engine, into one. That drastically increases our speed and accuracy, and we call that the speech to meaning engine. And it also helps improve our voice recognition because we understand what kind of queries would the users be asking based on the domains that they have enabled on the platform and the past conversations that they have had. Additional wins in accuracy are also attributed due to improvement in our deep learning models. So we have collected data from thousands of speakers in real life with noise conditions with accents under our Shepherd project. And therefore, we can perform robustly in noisy conditions even for users who have accents because we can apply specific acoustic models that have been trained to improve comprehension under those conditions. So now that we can process queries, what are some of the core ingredients of building a good voice AI? Well, according to us, it's these four. First, it should be able to answer a broad set of queries. So users should have the ability to ask from the platform anything from weather to stock price to flight status to restaurant reservations to flight bookings, etc. And how are we able to support all these broad set of queries? We do it on the platform with this concept called domains. So think of them as little building blocks that you can enable in your application that enable certain voice functionality. They are like Lego pieces. You can select the ones that you want and they work well with each other. And all of these domains are built using our own proprietary language, which is Terrier, which is a derivative of C++, and we use it to constantly improve the experience for our users. Since domains are modular, they can grow over time to understand more meaning and more complex queries. So they understand better depth and breadth. An example of breadth would be if I ask the nutrition domain to give me the calorific content of a banana, an apple, or a Big Mac, and it should be able to answer all those queries for me. And the example of depth would be asking the nutrition domain to give me the calorific content of a Big Mac if I remove sauce and cheese. So over time, both of these dimensions grow, and we are able to deliver progressively better experiences for our users. Some other advantages of using domains on our platform are as follows. Number one, they cover a lot of different possibilities. We have over 175 domains available. They can interact well with each other. So let's say if I make a query asking the platform to give me directions to the nearest sushi restaurant, I can enable the map domain, the location domain, and the restaurant domain. And the location domain will feed into the restaurant domain. The restaurant domain will feed in data to the map domain, and it can give me the directions. It can be added or removed in real time. So once you deploy your application, you can still enable certain domains, and that will enable voice functionality to your applications. They're quite modular, which is self-explanatory. They can be public or private. They're quite easy to learn and use. Actually, you can go on the Roundify platform right now, sign up, and build your first voice-enabled application within the first 15 minutes. More domains means they're faster to build, pretty much because we already have all the infrastructure in place, and they're quite personalizable. The second ingredient to building a great voice AI is its ability to understand meaning, especially for human speech that can have specific actions, double negatives, comparisons, and more. So let's take this as an example. If I make a query asking the platform to show me hotels in San Francisco for tomorrow that are less than $300 but not less than $200, are pet friendly, have a gym and a pool, and don't include anything that doesn't have Wi-Fi. So you see the maroon section is the base query. The blue section are more specifications that I've added to simplify my results. And the pink section is the double negative. And then I can make a subsequent query asking the system to sort my results by lowest price. And then I can also manipulate the original query asking question, what if I check in tonight and stay for 3 nights? And it should be able to understand all of these subsequent occurrences and still keep my context relevant. So the way we are able to do that is using our deep meaning understanding engine. And it's set up as follows. The sections in red are the domains that give us the weighted patterns. They have the large data structures and the programmatic instructions that are helping refine the context on the fly. The green sections are the acoustic models that give you contextual neural networks and the statistical models. And the section in the blue is the conversation state that reads in what kind of queries you've asked in the past and further give you more relevant responses for your future queries. So, some of the advantages of using the deep meaning understanding engine is the fact that it can understand arbitrary complex conversations. It automatically creates a searchable space of all of the possible queries you could ask. It performs extremely fast search in real time. It can dynamically change the search space as you add or remove domains. It avoids early classifications. Of course, it uses the context from your previous queries, and it's quite scalable. So, an example of this would be if I enable the sports and the calendar domain, and I ask a query to show me the next Leafs game, it understands that I'm talking about the Maple Leafs team and not the actual Leafs from the tree. The third ingredient is for the system to have relevant conversations with the users. So take this example. If I make a query asking Quantify to show me coffee shops nearby, and then make a secondary query asking it to show me the ones that have Wi-Fi, and then ask a third query to sort it by ratings, and then make the fourth query to show me the directions to that coffee shop. Well, while I'm having this conversation with a human being, you can understand the intents as I'm talking to you. But for a system, it often loses context as you're going through this dialogue flow. So we are able to make this work because of this concept called conversation state, where when I make my first query to show me the coffee shop nearby, it returns a response and it has an object in my conversation state. And when I pass the conversation state with my second query in my request, I get another conversation state in my response that contains 2 objects. So it can retain the context of my previous query and my current query. When I make my third query, I pass in the conversation state from step 2, and it returns a conversation state with 3 objects. And I can keep on having a dialogue-like flow with the system and serially keep on adding more conversation states in my response. The fourth ingredient is the fact that system should be customizable. And we allow that on Quantify with domains. So this is what our orientation might look like if you were to make a smart home application. This is if you were to make a travel app. You can enable the navigation domain, the Uber domain, the maps, and the flight booking domain. This is what it might look like if you're building a personal assistant. And there might be some queries that our platform does not support right now. And in order to cover those scenarios, we have created these 2 domains that allow you to create custom commands. So this is very interesting. So the custom commands are built in live Terrier syntax, and it allows you to create these expressions, and anytime a user says anything that matches these expressions, it will return the result JSON back. So the dot is an AND operator here, a vertical line is an OR operator, and square brackets are the optional operators. So anytime I say any one of these 7 occurrences, it can identify the query and return a response back. So now when I ask the system to turn on the lights, originally that query was not supported. After creating custom commands, I can identify the query and give me a response back. And actually you can try it too. Once you go back home, create a Quantify account, try these different queries, and you will be able to see responses, and you can customize those responses for yourself. Some other advanced features that we have built on our platform are as follows. We have the query group domain, which in itself does not answer any queries, but it's an infrastructure domain. It allows multiple domains to work well with each other. So now I can make a really complex query that has multiple intents. If I was making an automotive application, such as tune to 99.9 FM, recline my seat, turn on the AC, and open the window. And the system is able to understand this big query and able to give me a response back because of query 2. In addition to that, as I mentioned, we have specific speech recognition models that we have created for different languages in different conditions and even for speakers with accents, just to improve the accuracy and comprehension for the system. So, for example, if you're driving down and your windows are down and you have your radio turned on, you can use a different recognition model versus if your car is at a red light stop and it's completely quiet. Another concept is the fact that some queries need to be more personalized for our users. So for example, in our phone domain, you have the ability to upload all of your contact data from the phone. And then you can make queries like call mom or call Tom Ford or call Steve at his work phone number. And we are able to identify those queries because we know the data that's already uploaded from the user. Or you can use our home automation domain and specify all of the devices, all the IoT devices that are connected to the internet, and then make a query like turn on the living room light, and we know which light you're referring to that's in the living room. So therefore, with the user data storage, you can really personalize the query on the platform. And the last feature that we have is a phrase spotter, which allows for a completely hands-free experience on the platform. So you can simply invoke the entire application by saying OKHound and then make your query, and it's able to identify the full query and give you a response back. And the phrase spotter is also shipped with a client SDKs that you can try out. So our engineering dev manager actually built the smart mirror application that's on our GitHub repository, and you can try it out if you guys want. It's on the SoundHound GitHub. And it's using the Houndify platform, and it's able to, every morning he uses it to get answers for weather, for different stocks that he has invested in. It's a pretty cool app. So we are going to be at the career fair tomorrow. Our booth number is 77, right outside this room. Do come and drop by and say hi. If you are interested in some of the cool work that we are doing, and we are looking for a lot of developers, and we are expanding in Toronto, so definitely come and talk to us. This is our pictures from last year's career fair, and there at the top right is Jonathan James at the bottom right, and that's Jason on the left. And that's the end of my presentation. Thank you so much for your time. I'll open the floor to any question and answers. I would also like to invite JJ, Vanessa, and Jason onto the stage.